mystery of the bizarre UFO formation on Mars is solved. Scientists claim it was created by massive volcanic eruptions 3 billion years ago. The mystery of a strange Martian rock formation that has baffled scientists for decades has now been solved. Since its discovery in the 1960s, researchers have been trying to work out exactly what causes the undulating hills and sharp ridges of the Mijisi-Fossey Formation. The formation covers an area of about 2 million square kilometer, 770,000 square miles, around the Martian equator and is described by NASA as an enigmatic pile of eroding sediments. In the absence of any scientific explanation, conspiracy theorists have said that at least some of the exotic shapes found in the area belong to a crashed U.F.O. But a new study claims the rocks in this area of Mars are in fact the remains of volcanic eruptions that would have changed the climate of the red planet 3 billion years ago. The incredible formation is 1/5 as large as the continental United States and covers almost 10 times the area of the United Kingdom, meaning it could be the largest explosive volcanic deposit in the solar system. Scientists first observed the Mijisi-Fossey with NASA's Mariner spacecraft in the 1960s but were unsure whether wind, water, ice or volcanic eruptions deposited the mass of rock debris. In 2016, conspiracy theorists even claimed the formation was a crashed spacecraft from an alien civilization. Using photographs released by NASA, YouTube channel UFOvni 2012 put their own spin on the origins of the large geological unit of uncertain origin. If we take a look at the crash site, we see that the UFO, which is approximately 190 meters wide, impacted the surface at a low angle, landing up half buried in the Martian soil, UFO hunter Scott Waring, who runs the channel, said. The long and turned landing tracks left behind from the craft show that the ship crash-landed as gently as it could, he said. However, Nigel Watson, author of the UFO Investigation Manual, said it was more likely to be a natural geological formation. Scientists now say the formation of the Mijisi-Fossey would have marked a pivotal point in Mars's history and altered the climate of the red planet. This is a massive deposit, not only on a Martian scale, but also in terms of the solar system, because we do not know of any other deposit that is like this, said Lujendra Odha, a planetary scientist at Johns Hopkins University in Baltimore and lead author of the new study. The explosive eruption was so vast it would have ejected enough water to cover Mars in a global ocean more than 4 inches, 9 centimeters, thick, researchers said. Greenhouse gases exhaled during the eruptions could have warmed Mars' surface enough for water to remain liquid at its surface, according to the study, published in the Journal of Geophysical Research. However, toxic volcanic gases like hydrogen sulfide and sulfur dioxide would have also been spewed into the atmosphere. Researchers used data from various Mars orbiter spacecraft to measure the Mijisi-Fossey's density for the first time. They found the rock is unusually porous and is about 2/3 as dense as the rest of the Martian crust. They also used radar and gravity data to show the Mijisi-Fossey's density cannot be explained by the presence of ice, which is much less dense than rock. Because the rock is so porous, they believe it must have been deposited by explosive volcanic eruptions. As much as half of the soft rock originally deposited during the eruptions has eroded away, leaving behind the hills and valleys seen in the Mijisi-Fossey today. Scientists know Mars has some water and carbon dioxide in its crust that allow explosive volcanic eruptions to happen on its surface. However, the planet's interior would have needed massive amounts of volatile gases, substances that become gas at low temperatures, to create a deposit of this size. If you were to distribute the Mijisi-Fossey globally, it would make a 9.7 meter, 32 foot, thick layer, Dr. Ojha said. Given the sheer magnitude of this deposit, it really is incredible because it implies that the magma was not only rich in volatiles and also that it had to be volatile rich for long periods of time. Future gravity surveys could help distinguish between ice, sediments and igneous rocks in the upper crust of the planet, Kevin Lewis, a planetary scientist at Johns Hopkins University and co-author of the new study. The new finding could add to scientists' understanding of Mars's interior and its past potential for habitability, according to the study's authors. Earlier this year, researchers found oceans on Mars formed 300 million years earlier than first thought. Research suggests the planet's water systems appeared after a series of massive volcanic eruptions permanently altered the planet's surface around 4 billion years ago. The formation of Mars's oceans was linked to the violent rise of Tharsis, a 3,000-mile, 5,000 kilometers wide string of volcanoes that make up the solar system's largest volcanic system. Tharsis likely spewed gases into the atmosphere that created a global warming or greenhouse effect, which allowed liquid water to exist on the planet. Nearly a third of the surface of Mars was covered by oceans of liquid water early in the planet's geological history, but how they formed has largely remained a mystery. Study lead author and UC Berkeley scientist Dr. Michael Mangas said, "The assumption was that Tharsis formed quickly and early, rather than gradually, and that the oceans came later. We are saying that the oceans predate and accompany the lava outpourings that made Tharsis. Volcanoes may be important in creating the conditions for Mars to be wet. Eruptions triggered by the volcanic system also created channels that allowed underground water to reach the surface and fill the northern plains," Dr. Mangas said.